A neutron source emits high-energy neutrons into the formation. The individual neutrons collide with nuclei of atoms in the formation. Each collision reduces the energy level of the impacting neutron until it reaches an intermediate energy level. At this energy state, a neutron is called an epithermal neutron. As epithermal neutrons collide with more nuclei, they lose additional energy until they come into general equilibrium with the surrounding nuclei. At this level, they are called thermal neutrons. Most neutron tools detect returning thermal neutrons.
Now, because of size similarities, the common chemical element that is by far the most effective at degrading neutrons from high energy to epithermal to thermal levels is hydrogen. When neutrons reach the low-energy thermal equilibrium level, they are very susceptible to capture by nuclei in the formation. When neutron capture occurs, a gamma ray is released. This capture gamma ray is detected and is proportional to the amount of hydrogen in the formation.
When the tool is in the hole, high-energy neutrons penetrate the mud cake and formation as they start their degradation through epithermal to thermal neutrons. As they move away from the source, a thermal neutron flux, or gradient, is established that depends upon the collision rate between the formation nuclei and the neutrons. The flux rate declines with distance from source, and at a different rate or slope depending upon porosity. This relationship of neutron flux to porosity is mostly the result of hydrogen in the water molecules filling pore spaces. High initial thermal flux rate and rapid decline is to be expected with high porosity because of the abundance of water. The inverse, low initial thermal flux rate and slow decline, is to be expected with low porosity.